With more than 20 million mattresses discarded every single year, the United States faces a massive waste problem most people never think about. Old mattresses are bulky, heavy, and nearly impossible to compact. They clog landfills, jam waste equipment, and consume enormous amounts of space. In fact, a single mattress can take up as much landfill volume as dozens of household trash bags. But here's the part very few people know. In America, mattresses are no longer just trash. They are a valuable source of steel, foam, fiber, and fabric. And this has created a massive hidden industry dedicated to taking mattresses apart piece by piece. Mattresses weren't always a recycling problem. For most of history, mattresses were simple: straw, wool, cotton, or horsehair stuffed into fabric shells. When they wore out, they decomposed naturally. But the modern mattress changed everything. Today's mattresses are complex industrial products: steel springs, high-density polyurethane foam, memory foam layers, synthetic fibers, fire-retardant barriers, fabrics engineered for durability. A single mattress can contain up to 70% steel by weight, along with multiple layers of petroleum-based materials that do not break down naturally. As mattress consumption increased, disposal became a crisis. Landfills filled with bulky mattresses that refused to compress. Waste facilities struggled as steel springs tangled machinery. Cities faced rising disposal costs. Something had to change. That change came through regulation and economics. Several U.S. states introduced extended producer responsibility laws, requiring mattress manufacturers and retailers to fund recycling programs. Instead of dumping mattresses, they would now be collected, dismantled, and recycled. This legal shift gave birth to one of the most unusual recycling industries in the country. The journey of a recycled mattress begins far from the recycling plant. It starts in bedrooms, hotels, dormitories, hospitals, and apartment buildings across the nation. When a mattress reaches the end of its usable life, it is removed during renovations, upgrades, or replacements. Retailers often offer mattress take-back services. Municipal waste programs collect discarded mattresses separately. Hotels replace hundreds at a time. Universities clear out entire dorm buildings in a single week. Each of these locations feeds into the recycling network. Trucks designed specifically for bulky waste collect the mattresses and transport them to regional recycling plants. Some facilities handle thousands of mattresses per day, stacking them in towering piles that stretch across industrial yards. These mountains of mattresses are not chaos, they are inventory. Once inside the plant, the real work begins. Unlike paper or plastic recycling, mattress recycling is not automated melting or shredding, it is industrial disassembly, a controlled, methodical teardown of a complex product. Workers wearing gloves, protective sleeves, and safety glasses move mattresses onto processing tables or conveyor lines. The first step is opening the mattress shell. Using industrial cutting tools, workers slice through thick fabric and fire-resistant layers, peeling back the outer casing like skin. Immediately, the inner materials are exposed. Foam layers, cotton batting, synthetic fibers, and padding spill outward. These materials are removed by hand and sorted into dedicated streams. Foam goes one direction, fiber another, fabric another. Next comes the steel core, the most valuable component. Inside almost every traditional mattress is a dense network of steel springs or coils. These steel frames are heavy, rigid, and extremely durable. Workers cut and separate the steel structures from the remaining materials. In some plants, hydraulic shears and automated cutters assist with this stage, snapping steel coils into manageable sections. The speed is impressive. An experienced worker can dismantle a mattress in just a few minutes. Multiply that by dozens of workers on multiple lines, and the scale becomes clear. Large plants process tens of thousands of mattresses every week. Once separated, each material enters its own recycling pathway. The steel is compacted into dense bundles and shipped to scrap metal processors. There, it will be melted down and reused in construction steel, automotive parts, appliances, or even new mattress springs. This steel recovery alone prevents hundreds of thousands of tons of metal from being mined each year. Foam is the next major stream. Mattress foam is shredded into small pieces using industrial grinders. These foam flakes are compressed into large bales or processed further, depending on demand. Recycled foam is used in carpet padding, gym mats, soundproofing materials, furniture cushioning, and insulation products. What once supported someone's sleep now supports buildings, vehicles, and athletic facilities. Fiber materials, including cotton and synthetic blends, are cleaned and repurposed. Some become industrial padding, others are used as insulation or filtration material. Even mattress fabric finds new life as wiping cloths or filler material. Nothing happens by accident. Every step is optimized for recovery. Recycling plants aim to reclaim 80 to 90% of every mattress. Very little ends up as waste. As materials flow through the plant, logistics move just as fast. Forklifts shuttle bales of steel, foam, and fiber to loading docks. Trucks arrive and depart continuously, feeding downstream industries. This is not a slow, experimental process. It is a full-scale industrial operation. Technology plays a growing role. Some facilities now use automated conveyors to feed mattresses into disassembly zones. Others deploy mechanical cutters to reduce labor strain. Tracking systems record how many mattresses are processed, how much material is recovered, and where it goes. Every mattress is accounted for. The environmental impact is enormous. Recycling a single mattress saves landfill space equivalent to dozens of trash bags. It reduces demand for virgin steel and petroleum-based foam. It cuts greenhouse gas emissions associated with mining, refining, and manufacturing. In states with mandatory recycling, landfill pressure has dropped dramatically. But mattress recycling is not just about the environment. It is also about economics. Recovered steel and foam have real market value. Recycling creates jobs in collection, processing, transportation, and manufacturing. Entire regional economies now depend on this once unthinkable industry. What makes mattress recycling remarkable is how invisible it is. Consumers replace a mattress and never think about it again. They don't see the dismantling tables, the grinders, the steel bundles, or the foam bales. Yet this hidden system operates daily, quietly preventing a waste crisis, and the scale continues to grow. As populations increase and replacement cycles shorten, more mattresses enter the system every year. Recycling plants expand. New technologies emerge. What was once considered impossible waste is now a predictable material stream. So the next time you lie down on a mattress, remember its future. Remember that one day, it will not simply be thrown away. It will be taken apart, piece by piece, by a massive industrial network designed to recover value from what others see as garbage. If you enjoyed this journey into one of the most surprising hidden industries in America, make sure to like, subscribe, and hit the notification bell so you never miss our next deep dive into the systems that quietly keep the modern world moving. Thanks for watching. Millions of cars quietly reach the end of their lives. Some are damaged beyond repair in accidents. Others simply grow old, inefficient, or too costly to maintain. Instead, it begins a second life inside one of the largest and most powerful recycling systems in the modern world. Today we're taking you inside a supergiant scrap car recycling plant, where old vehicles are dismantled, shredded, separated, and reborn as brand new steel that fuels America's industries. The history of car recycling in America goes back more than a century. In the early days of automobiles, scrap cars were often abandoned, stripped by hand, or left to rust in junkyards. Steel was cheap, environmental awareness was low, and recycling was driven mostly by necessity during wartime. During World War II, scrap metal became a strategic resource, and Americans were encouraged to turn in old cars to support the war effort. That moment marked a turning point. After the war, as car ownership exploded, so did the volume of vehicles reaching the end of their useful life. By the mid-20th century, specialized auto salvage yards and metal recyclers began transforming scrap cars into a reliable source of steel. Today, car recycling is not just an environmental choice, it's a cornerstone of America's industrial economy. In modern America, between 12 and 15 million vehicles are recycled every single year. That makes cars the most recycled consumer product in the country. On average, more than 85% of a vehicle's weight is recovered and reused. Steel, aluminum, copper, plastics, rubber, almost nothing goes to waste, and it all starts the moment a car enters a recycling facility. The process begins at auto salvage yards, where end-of-life vehicles arrive by tow truck from dealerships, insurance companies, auctions, and private owners. At first glance, these yards may look chaotic, but they operate with careful organization. Each vehicle is logged, identified, and prepared for depollution, one of the most critical steps in the entire process. Before a car can be crushed or shredded, every hazardous fluid must be removed. Workers drain fuel, engine oil, transmission fluid, brake fluid, coolant, and refrigerants. Batteries are removed, airbags are safely discharged, and electronic components are extracted. This step protects workers, equipment, and the environment, ensuring nothing dangerous enters the recycling stream. Once depollution is complete, valuable reusable parts are removed. Engines, transmissions, alternators, doors, wheels, and electronics are carefully dismantled and sold into the used parts market. This reuse phase alone keeps millions of affordable parts available for repairs, extending the life of other vehicles and reducing the need for new manufacturing. Only after reusable components are recovered does the remaining vehicle body move forward, now stripped down and ready for its transformation. The next stop is the crusher. In a matter of seconds, a full-size car is compressed into a dense steel cube. These crushed vehicles are stacked and transported to the heart of the recycling operation, the shredder plant. Here is where the scale becomes truly jaw-dropping. Industrial shredders stand several stories tall, powered by motors producing thousands of horsepower. When a car enters the shredder, massive rotating hammers tear it apart with explosive force. Steel, aluminum, glass, plastic, rubber, everything is shattered into thousands of fragments in just moments. What comes out of the shredder looks like chaos, but this is where advanced technology takes over. The mixed material flows onto conveyor belts and enters a sophisticated separation system. Powerful magnets instantly pull out ferrous metals, primarily steel, forming the backbone of recycled metal production. This steel stream alone accounts for millions of tons per year and is the primary reason scrap cars are so valuable to American steelmakers. Next comes non-ferrous separation. Eddy current systems use magnetic fields to eject aluminum and other non-magnetic metals from the stream. Optical sensors and air classifiers sort plastics, foams, and fibers. Copper wiring is recovered for reuse in electrical applications. Even rubber from tires finds new life in asphalt, playground surfaces, and industrial products. Step by step, what once was a single vehicle becomes dozens of reusable material streams. The recovered steel is then processed, cleaned, and compacted into massive bundles or shredded steel scrap. From here, it travels to steel mills across the country. In electric arc furnaces, recycled steel is melted at extreme temperatures and refined into new steel products. This recycled steel becomes the raw material for construction beams, rebar, appliances, tools, and even brand new cars. In fact, much of the steel used in modern American vehicles comes directly from old ones, completing a powerful circular loop. The environmental impact of this process is enormous. Recycling steel from scrap cars saves about 74% of the energy required to produce steel from iron ore. It reduces mining, lowers carbon emissions, and conserves natural resources. Every ton of recycled steel saves thousands of pounds of raw materials and significant amounts of water and energy. In a world facing growing environmental challenges, scrap car recycling is one of America's quiet sustainability success stories. Behind this massive operation are skilled workers and engineers who keep the system running smoothly. Operators monitor shredders and separation lines around the clock. Maintenance teams ensure machines capable of destroying cars every few seconds continue to function safely. Data systems track material recovery rates to maximize efficiency. What once was a scrapyard industry has evolved into a high-tech recycling powerhouse. Perhaps the most remarkable part of the scrap car recycling story is how invisible it is to everyday life. Drivers trade in old vehicles without thinking twice. New cars roll off assembly lines without revealing their recycled origins. Yet beneath the surface, a vast industrial network is constantly at work, turning yesterday's vehicles into tomorrow's infrastructure. A car that once carried a family across highways may now be part of a bridge, a skyscraper, or another vehicle entirely. Steel forged from scrap cars becomes the backbone of modern civilization, proving that even in an age of constant consumption, renewal is possible. If you enjoyed this inside look at one of America's most powerful recycling industries, make sure to like, subscribe, and turn on the notification bell. We'll continue exploring the massive processes that turn waste into resources and keep the modern world running. Thanks for watching, and as always, stay curious.